In this lesson, we're going to start talking about what the derivative is going to tell us. So it's going to give us some hints and information about our graph and the direction that it might be going, such as pieces that are increasing or decreasing on our graphs. So remember that the derivative tells you about slope. And so if we have a graph that's increasing, we also have a graph that has a positive slope, which would mean that our derivative would have to be greater than 0 everywhere because that represents slope, and a positive slope is going to be greater than 0. So if we have a slope that is greater than 0, we also have an increasing section. So increasing section also refers to a positive slope. And the opposite is true. So if you have a graph that's decreasing, that means we're going to have a negative slope. So decreasing is going to refer to a negative slope. Which would mean whatever derivative we get, it's going to be less than 0. All right, so that's it. That's our quick connection is if we're talking about a slope that is positive, we're going to be talking about a slope that or a graph that's increasing. If we have a slope that's negative, we're going to have a section that's decreasing. So let's put it into an example. So they're telling us a bunch of information, and we're going to try to see if we can figure out some sort of a visual representation for this. So we have a slope that is positive from intervals -infinity to 0, 4 to 6, and 6 to infinity. We have a slope that is negative, so we have a decreasing section. So this is an increasing section. This is a decreasing section because we have a negative slope from 0 to 4. We have a slope that is undefined. We're going to come back to that. And we have, at these particular points, a slope of 0. So a slope of 0 means we are an extrema, potential extrema. So it might be a maximum, it might be a minimum, and it might be a level off. No matter what, it's kind of leveling off because you have a slope of 0. Right? The slope of 0 looks like that. So it's leveling off, but it's at an instantaneous moment. This level off might be what I call a chair. I'll show you the visuals for that in a second. And then undefined. We have a couple different situations where it's undefined. And undefined is a vertical slope. The vertical slope is because your rise over run, you have no run. And so it's going to be something over 0. So undefined could mean a couple things. It could mean that we have an asymptote. It could mean that we have a cusp. Or it could mean that we have a corner. Okay, so a couple different things that are happening. First off, it is continuous. So if it's continuous, we're not going to have an asymptote. But we might have a cusp or a corner. So a cusp would be something that kind of, or I suppose another look could be something like that. A cusp is when you have a graph that kind of comes down like this and then goes back up. A corner would just be kind of more like an absolute value kind of a thing. And the idea for the undefined is because it's not differentiable. Differentiable means that you're going to be having this nice transition from one kind of a slope to another, and this has a very abrupt kind of a change in it. So this could look like this. It could be a cusp, could be a corner, a bunch of different things. So let's put all this together and see what we can come up with. So what I like to do is I try to draw some sort of like a number line to kind of reference it, and then we'll draw an actual nice graph to it. So some critical points that we have are -infinity to 0. So 0, 4 to 6, and then 6 on. So from -infinity to 0, we have a positive slope. And then from 0 to 4, we have a negative slope. And then at 4 to 6, we have a positive slope. And then 6 to infinity, we have a positive slope. So visually, types of things that we have going on is at 0, we have undefined, right? So we have this type of stuff going on. It could be something like this, right? Where we have a vertical slope at that point. And then at 4, we have a slope of 0, and we have a negative slope to the left and a positive slope to the right. So it was going down, and then it hit a slope of 0, and then it started to go back up, right? Because it was decreasing and then increasing. And then at 6, we have a positive slope, and then hitting a slope of 0 at 6, and then it goes positive again. So that's the chair idea, that it levels off for a second, but then it keeps on going up. So it's not a maximum, it's not a minimum, but it does hit a slope of 0. So if I put all those pieces together, let's see what we can build. So we have 1, 2, 3, 4, 5, 6. So 2, 4, 6, and 0. So we have, let's see, we have a minimum at 4. We have kind of this chair look at 6. And then at 0, we don't know. I don't have a ton of space, so I'm going to do my best. So we have a chair kind of a look that hits a minimum. All right, so then we're going to go back up. And then at 0, we're going to try to hit some sort of a cusp, a corner, or a vertical slope. We can make it whatever we want. So we don't have any more information, so we'll just say it does something like this. All right, so we have our minimum, we have our chair, and we have some sort of an undefined slope, which could mean a couple different things, but we don't have enough information to go any further than that. So that's a little bit of information about, or it's a beginning of talking about what the derivative is telling us. This is a little bit, we'll dive deeper into some other problems.